Question is, the motion of a particle executing simple harmonic motion is described by the displacement function x of t is equal to a cos omega t plus theta if the initial position of the particle is 1 centimeter. So x is equal to, so that is initial position 1 centimeter, and its initial velocity v is equal to omega centimeter per second, right? So that is centimeter per second. What are its amplitude and initial phase angle? The angular frequency of particle omega is equal to pi second inverse. If instead of the cosine function, okay, so first of all we have to find amplitude and initial phase angle. So first of all, x is equal to, that formula is a cos omega t plus theta, right? Now initially, that is 1 a cos, now t is 0, so cos theta only, so a cos theta is equal to 1. Now for velocity, v is equal to minus a sin omega t plus theta. Now we know that v is equal to omega, right? Again, see, if this is x, a cos omega t plus theta, v will be minus a. Why? Because cos differentiation is minus sin. Now again we have to differentiate this bracket also. So omega t differentiation, omega is constant, so that's why I have to write here omega here, and dt by dt 1, theta is constant, that's why 0. So we are left with this a omega also. Now we know that v formula is omega by putting here omega is equal to minus a omega sin omega t plus theta. Now omega gets cancelled out, and also left hand side we are left with 1 is equal to minus a sin. Now we are talking about t is equal to 0 times, so theta, so I can write a sin theta is equal to minus 1. So this is my first equation and this is my second equation. Now squaring both the equations, and sum of that equation is square cos square theta plus a square sin square theta is equal to 1 square plus 1 square is equal to 2. If a square common, cos square theta plus sin square theta will be 1, so is equal to 2. So a is equal to under root 2. So that is the value of root 2, that is amplitude, right? Initial. Now initial phase angle, so initial phase angle tan phi is equal to that formula is now sin theta upon cos theta, right? Sin value is minus 1 upon 1, so phi is 3 pi by 4, then 7 pi by 4, and so on, right? So that is our initial phase angles. Now question is that we choose the sine function to describe SHM, right? So now if my x is equal to, our new x is equal to b sin beta omega t plus alpha, this is my new function. Now again, what are the amplitude and initial phase of the particle with the above initial conditions? Now again 1 b sin this is 0, t is 0, so that's why only alpha, so b sin alpha is equal to 1. Now v is equal to, directly I am writing b into omega, sin differentiation is plus, so that's why I have to write plus here, there is no negative sign, sin differentiation is cos, so cos omega t plus alpha, so that is v. Now v, earlier we discussed that omega, so omega is equal to b omega cos, now again t is equal to 0, so only alpha, so omega gets cancelled out, again 1 is equal to b cos alpha. Now again square both the equations and sum both the equations, so b square sin square alpha plus b square cos square alpha is equal to 1 square plus 1 square, right? B square common, sin square plus cos square will be, so that b square is equal to 2 means b is equal to root 2. Now here we need to find that alpha, right, initial phase. So tan alpha formula is equal to sin alpha upon cos alpha. Now both of them are 1 upon 1, so alpha is pi by 4 and so on. So that is our initial phase.